Welcome back as we're continuing our journey through some data visualization stuff. We're really talking mostly about some basic plots and how we can interpret them. And the next one we have up in our list is a scatter plot. And we're actually going to talk about scatter plots and line graphs, which covers two lessons. We're going to cover those both in this video as they're very highly sort of correlated or connected with each other. Now, a scatter plot is a type of graph which usually utilizes Cartesian coordinates, and typically we're talking about displaying values for two variables of a data set, or maybe one variable spread over some period of time, right? But in general, we have two values: one that we're going to represent on the x-axis and one on the y-axis, and much like we've set up our mathematical equations, a lot of times the x-axis will be sort of dependent on, or excuse me, the y-axis will be dependent on the x-axis, right? So maybe the x-axis represents time and the y-axis represents some measurement, right? That measurement is sort of a function of the time, right? It's dependent on something else, or we're looking how it trends over time. But if we look at this, here we actually have two variables, right? One on the x-axis, one on the y-axis. And as I mentioned, the data being displayed on the x-axis, the x variable is a little bit more likely to be the independent, right? It looks like these might actually not have a ton of correlation. There does seem to be some correlation, but it's not super clear. But on the x-axis, we have miles per gallon, and it looks like our lowest rating was just above 10, and our highest rating was approaching 40, or maybe just above 40, and then a rear axle ratio, right? And we can see in general, cars that have a higher miles per gallon tend to also have a higher rear axle ratio. Although this isn't a super strong correlation, but this is a very common sort of scatter plot, right? This is however many dots there are is how many data points I have in my data set. And I've taken two fields or sort of columns of that data set, one being miles per gallon, the other being rear axle ratio, and I plotted them against each other, right? How does the rear axle ratio change in relation to the miles per gallon? Or is there no correlation between those two at all? So I'm looking at, right, miles per gallon on the x-axis. That will be sort of one column in a table full of data versus rear axle ratio, which is another column in a table full of data. And you just sort of plot those as x and y coordinates, adjust and label the scales appropriately, and you can sort of see how one variable relates to the other. Now, if we look at some data that's from the same data set but was chosen a little bit more scrupulously to be data which is correlated, now I'm looking at engine displacement versus miles per gallon. Right. And again, my sort of more independent of the two variables, my engine displacement will be on the x-axis, and my miles per gallon, just intuitively knowing how a car works, I know that's likely to be a function of my engine displacement, right? There is likely to be a correlation between these two variables in that a larger engine will use more fuel, right? And we can see that there is a pretty clear correlation here, right? As my x variable increases, my y variable pretty expectedly, or like I could depend on it to pretty consistently go down, right? As my engine gets larger, my efficiency goes down. I get fewer miles per gallon, right? And it turns out that we can actually quantify this relationship that we see on a scatter plot by sometimes fitting a line, right? And this is a best fit line. I know when I was in, maybe it was algebra or trigonometry, we sort of had exercises like this, and we just sort of eyeballed it, right? You would plot a bunch of points and then take a ruler on your little pencil and paper graph paper and draw a line that best represented the relationship between those two things. And maybe you would calculate the slope of that line and use it to make predictions, things of that nature, right? It turns out that's actually called linear regression. This is something that you're going to cover somewhat in depth in the DSI. But it's important to sort of know or understand that one of the most common uses for a scatter plot in data science is going to be in the context of making linear regressions, right? When you're trying to quantify the relationship of one variable with respect to some other variable. In this case, we're trying to quantify the relationship between miles per gallon and engine displacement. We're not going to dig into the math of linear regression here, but just talk about visually, sort of what that means. And again, right, one thing I didn't mention, right, the slope of this sort of correlation line, or in general, correlation between these two data points, these two columns of my data set, the slope of this line is negative, right? So we will say that that has a negative correlation, right? As my x variable increases, my y variable decreases, or as my y variable increases, say if I'm an engineer for a car manufacturer, and I'm saying I want to achieve a miles per gallon of 30 miles, right? What size of engine in cubic inches am I likely to need, right? To achieve that level of efficiency. I could see here, from my regression line, if I want 25 miles, I might start with an engine that has about 100 cubic inches of displacement. But this is negatively correlated, right? When one variable increases, the other moves in the opposite direction, right? Conversely, we have positively correlated data, which, as you would guess, as one variable increases, in this case, the engine displacement, again, on the x-axis gets larger, right? We would also expect our horsepower to increase, right? So as one variable increases, the other is likely to increase as well. Again, from a designer's point of view, hey, I want to make a truck that has 200 horsepower. Approximately how large of an engine am I going to need, right? It looks like maybe 360 cubic inches or so, right? If I want more horsepower, right, I'm likely to need a larger engine. If I want less horsepower, I'm likely to need a smaller engine. These two variables or fields or attributes of each of these data points are positively correlated. When one increases, the other moves in the same direction. Right. So that's typically how we'll see a scatter plot used as data scientists, right? We can use it to make predictions, as I sort of was, right? I can say, if I have a 300 cubic inch engine, what's my horsepower likely to be? Looks like about 175, right? That's a good starting point for an estimation, right? We can also use scatter plots, right? So that's I would say the most common use of a scatter plot that you're going to use as a data scientist. You might use a scatter plot in time series data where time is on your x-axis. I think we'll see a little bit of that in our next lesson on line graphs. But linear regression is often what you'll use scatter plots for as a data scientist, or need to interpret them as a data scientist. But we can also make scatter plots that are a lot more detailed, pretty visually appealing, and also describe a large number of variables, right? Here we have the same data set, but we have a number of variables expressed in that data set. Right now we're looking at, again, miles per gallon as a function of engine displacement, right? But each one of these, and we have this plot here, right? Each one of these dots represents a car that has some engine displacement, some number of cylinders, some miles per gallon, some horsepower, so on and so forth, right? And we can express all of those things in this same plot, right? By using different shapes for the number of cylinders, by adjusting the size of the point based on the number of horsepower that engine has, and also look at the weight of the car on a color gradient, right? And I think that you'll see that there's some nice trends that we can see here, right? We have sort of what I would classify as likely to be economy cars, right? Having over 20 miles a gallon efficiency, all having 4 cylinders, all being relatively small engines, less than 200 cubic inches. Actually, it looks like less than 150 cubic inches, right? And then as we sort of, we can also see all of those are pretty dark, right? These are also going to be in pretty light cars in general, right? You're not going to have a small engine in a big old truck, right? Then we have this sort of like sedan or maybe small SUV cluster here of triangles. You know, here we're having more cylinders. From that more cylinders, we're generally talking about larger engines that have less efficiency. But we do see the points are also a bit larger, right? So these are also in larger vehicles. And then our last sort of cluster, right? We're dealing with 8-cylinder vehicles. Maybe they're cars, maybe they're sports cars, maybe they're trucks, but a lot of these might be like work type vehicles that have an 8-cylinder engine. They are more likely to be high in weight as the engine size and efficiency decreases. Of course, it's going to take more gasoline to move more weight, something that's heavier. It's also going to take more horsepower. And we can see that these have a tendency to be a bit larger there, right? So a really useful way of how we could use scatter plots. Now, the last thing that we're going to do is we're going to jump into this line graphs. Actually, you know what? We're going to save line graphs. We're going to give it its own video, just the way all the others do. So let's go ahead and wrap up for this one. I can see you over in the next video. We'll talk about line graphs. We'll talk about how they're really similar to scatter plots. And then we're just about done with this common plotting section. We're going to talk about box plots, which we mentioned does have a relationship with the 5-number summary. And then we're going to move on back into some more traditional mathematics as we move forward. But that's it for this lesson on scatter plots. Look forward to seeing you over in the next video, which is all about line graphs.